Hi everybody, I'm the greatest living inventor, and today we are doing my invention, Bacterial Radar. Okay, so I'll write it down. Bacterial Radar. Okay, bacterial, you know what it is. Bacteria, tiny creatures, and germs. And radar means, normally it means like a sonar, like something that makes a wave, and then the waves hit something, and some of the reflection comes back, and we know how far this something is, like in the dark or something. But here it's in the context of just knowing where things are, where there is not enough light. Okay, so in the dark, like a bat. Okay, like a flying bat knows where he is using sonar, which is actually a form of radar. So a radar is on other waves based on electromagnetic waves, and a bat uses sound waves, but he knows where he is using some form of radar. So here a bacteria uses another kind of waves to know where it is. It's not exactly radar, but that's the closest thing that I could think of, that you know what it is right away. If I would rename the invention to be more exact, it would be bacterial sandstone. Okay, sandstone is a device that the Vikings used. When they went with their ships to the sea, and they needed to find the sun in order to navigate. Okay, I'll just take off my jacket because I'm hot. Okay, so bacterial radar or bacterial sandstone. Now the creature, the bacteria that we are talking about, is a very specific bacteria that is called Achromatium oxaliferum. Okay, oxaliferum. Achromatium oxaliferum. Okay, I got you a picture from Wikipedia, thanks to Maple Ferryman. So thank you to Maple Ferryman, and we have a picture of this tiny creature. Okay, here you have two because they are dividing, but normally it's just one of them. And you know that bacteria divide when they want to multiply. So, and you see inside it there are all kinds of blobs. There are big blobs, which are this and this. These are calcite. Okay, calcite is a mineral, and there are little blobs which are sulfur. Okay, so it has calcite. Well, I'll read it to you, and then it will be more orderly. Okay, so achromatium oxaliferum, sorry. Achromatium oxaliferum. Achromatium, it means not color. Chrom is like a color in Latin. A means not, so it's not colored, so it's like transparent. And oxaliferum means something to do with the oxalic acid, okay, which is first was found in plants, in flowers, and it has this kind of acid which is also can connect to the calcium, but I'm not sure how. So I'm not. I don't want to talk where I don't understand. Okay, so it has this kind of acid, but we are more interested in this creature because it has, and also it's very big. It's like 10,000 times bigger than normal bacteria, but we are interested in it now because it has calcite. Okay, calcite. Okay, so these big blobs that I shown you inside the creature is calcite. Okay, so achromatium oxaliferum is the only one known bacterium in which calcium Ca++, I'll erase this and I'll bring this to here. Calcium Ca++. This is chemically how you say calcium. Is deposited in calcite crystals, crystallized calcium carbonate. No one knows why. Okay, so I'm just writing this: calcite crystals. Which are crystallized calcium carbonate. Okay, so it has this calcite inside. Okay, and no one knows why. Okay, this is the source of the invention. Okay, like why I thought about it. Okay, so and the invention is what I thought might be the answer. Okay, I'm not sure, but it's a theory. Okay. So you can see what this special microbe looks like in this nice video Achromatium oxaliferum by Michael Marie Solito de Solis. Okay, so there is, I'm erasing, thank you, the picture is by Maple Ferryman from Wikipedia, and the video is by Michael, I'm sorry, not Michael, Michel, I'm sorry, I'm sorry, Michel Marie Solito. Michel Marie Solito de Solis. Okay, so if you write this and her name, Michel Marie Solito de Solis, you get this YouTube video, which you can see the creature in action. Okay, moving. Okay, the Viking. Okay, now I'm erasing and explaining how this, the calcite, the crystal, or in whatever you call it, these are other names for the same thing. It's a form, it's a special form of calcium. So now I'm explaining how the Vikings, okay, these ancient people from Scandinavia, used this material. Okay. Okay, so now we are talking about the Vikings. And they had something that is called sandstone. Okay, so what is the Viking sandstone? The Vikings used this material, the calcite, to navigate their ships at sea. In this context, the mineral is called Iceland spar. Okay, so Iceland spar. I hope I'm pronouncing this right. Iceland spar, maybe it's Iceland spare, I don't know. And as a navigation instrument, it's called sandstone. Okay, you can watch an explanation in this interesting video, The Sandstone Secret of Viking Navigation by Terra Incognita. Okay, so there is a video by Terra Incognita. Called Secret of Viking Navigation, The Sandstone Secret of Viking Navigation. Okay. Okay, so you can see the video. It's like they say that it's like a piece of glass, but special from this material, calcite, that you hold, you mark some spot on it, and it breaks like if you have this material. Okay, this is transparent, it's like glass. Okay, so if you put some light in it, like a laser, it breaks into 2. Okay, so it has one exit and another exit. Okay, so from 1 you get 2. So if you look at something through this, you see it double. This is a calcite. Okay, this is a sandstone or Iceland spar or calcite. It's the same. These are all words for the same thing. So if you have a block of calcite, which means sandstone or Iceland spar, you see things through it double. But if you look directly towards the sun, even if there are clouds in the sky, it's explained really well in the video. But if you look towards the sky and there are clouds, but the sun is beyond the clouds, and you don't know exactly where the sun is, and you need it for navigation, the sun location. So once you see it as 1, then you know that you are looking in the towards the position of the sun. Okay, because in any other direction there are 2 images, and if you see one direction, then it's they combine. The way it works, it's like physically it polarizes the light. Okay, so this is polarized. Let's say what comes inside is light, and what comes outside is polarized light. Polarized light is basically if you have like a rope, okay, and you move it up and down, okay, like between 2 people, and each one of us lifts and lowers the rope, then we have this movement in the rope. Okay, so this is one polarization. But if we move the rope to the right and to the left, okay, each one of us, then this is another polarization. Okay, this is like I don't know how to draw this, but it's another polarization. Okay, it's like this. So basically this is polarization in the real physical world, and in light. Light also has a direction. Like sunglasses polarize the light, so it's they bring you less light. Okay, only light that is in specific polarization, that the waves of the light are in specific polarization. This is also how 3D glasses in the cinema works. One eye has that polarization, and the other eye has another polarization, and the image is one frame is made with this polarization, and the next frame is made with the other polarization. So you see, each eye sees only the image that is for that eye. Okay, so it's not really important. I'm just saying that the calcite is polarizing the light. Polarize the light. Okay, and this means that if light okay, I don't want to make it complicated for you, just one other fact about polarization. If we have one polarization, okay, one filter, which has like this polarization, and another filter that has another polarization, okay, so if we put them together, it blocks all the light, okay, unless they have the same polarization, okay, because it's like this one blocks, let's say, the light that goes from left to right, this one blocks the light that goes from up to down, and they block together. If we put them one on each other and look through them, it blocks all the light. Okay, so I hope it's clear. It's long to explain, so I don't want to do this like a lecture on polarization. If you look what is polarized light in Wikipedia, you'll see a lot of examples, a lot of videos. Okay, so maybe if the crystals in the creature are transparent, but we see the creature as opaque, because we see the light entering in one side and exiting the creature on the other side, and the light passes two polarizers, okay, two crystals, which are not in the same angle, so very little light passes, like two filters. Okay, filter with some polarization, and this is a filter with another polarization, filter with another. Okay. Okay. But to the eye of the creature, like it doesn't have really an eye, but it has some sensitive to light it's not cell because it's one cell, but it's a huge cell. I told you it's 10,000 times the size of normal bacteria. So it's like it doesn't have an eye, but maybe it has some part inside which is sensitive to light. So this, let's call this the eye of the creature. So the eye of the creature, if it has something like that in its center, some part which is sensitive to light, each ray of light goes through one polarizer, just one polarizer only, so the creature can see polarized light. Okay, so the creature can identify polarized light, just like the Vikings identified the polarized light that is coming from the sun through this. Okay, so the creature has something like this inside, only very tiny. In fact, like a few like this. It has I showed you the picture. There are a few blobs like this inside the creature. Okay, so the creature can see a polarized light. Now, maybe. Now, the question, what is it good for? You can read in Wikipedia polarization and vision, which says it's good for navigation. Okay, so if you read in Wikipedia about polarization and vision, you can see that they say in Wikipedia that it's good for navigation. The creature lives in it lives in fresh water. Okay, I wrote mud, but it's more accurate to say fresh water, where there is like a lake, but where there is between places where there is oxygen and places that there isn't oxygen, like where it becomes more salty. Okay, so but generally fresh water, not in the sea. Okay, so the creature lives there, which means normally visibility is not good. Okay, because it's like there are a lot of minerals inside the where the creature lives. Okay, it lives in, imagine like if you put all kinds of minerals in the water, and for the creature who is very small, it's like big blobs that he needs to find out what's beyond them and so on. So the visibility is not very good, but the environment, I wrote the mud, but it's not the mud, it's the environment, is made of minerals, okay, which means crystals, and light goes through the crystals and becomes polarized. Okay, so this gives like this, but each mineral has its own polarization. So this gives the creature a view which is similar to radar. Okay, so the creature can, in principle, see, like the Vikings saw, recognize the sun through the clouds, okay, through the cloudy sky. So the creature recognizes the minerals that it needs, like to feed or something, through the, like sulfur or whatever it needs, through the obstacles, through the minerals that are in front of him, and he wants to see past them. Okay, plus maybe it can identify what's good to eat, identify certain minerals which are his food in this way. Okay, and also directions. Okay, so, like where the light comes from and where is it to navigate. Okay, so this was my invention, and I hope it was clear, and I'll see you in my next invention. So thank you very much. Thank you.